Hello guys, welcome to our channel Tektronics. Today we'll discuss about the semiconductor and diode part 2. So let's see what is the first topic. The first topic is the theory of p-n junction diode. So what is it? When two pieces of semiconductor materials, one doped with p-type impurity and other with n-type impurity are joined together, then a p-n junction diode is formed. N-type has a higher concentration of electrons and p-type has a high concentration of holes. So diffusion of carriers takes place across the junction. Diffusion is the process of movement of carriers from high concentration region to the lower concentration region. So this diffusion, and as electrons move from n-side to p-side, some of them recombines with hole but some of them does not. So due to lack of energy and becomes immobile ions and gets deposited near the junction. Same is also true for holes. Thus a barrier is set up near the junction consists of positive ions at the n side and electron at the p side. So a potential difference is set to up at the junction called barrier potential, which has a potential of V0. So the note is the value of V0 varies with doping level and temperature. So it means the value of barrier potential varies with doping level or doping concentration and temperature. The value of V0 is 0.3 volt for germanium and 0.7 for silicon. So it means the barrier potential for germanium is 0.3 volt and for silicon it is 0.7 volt. Depletion region is also known as space charge region, where the charges are immobile. Depending upon the different biasing conditions, we get p-n junction forward biased or reverse biased. Biasing is the application external field to the material so that it works properly. The next topic is the forward bias condition, which is very important for p-n junction diode. When the positive terminal of the battery is connected to the p side of the diode and the negative terminal of the battery is connected to the n side of the diode, then it is called to be forward bias condition. And when applied potential is greater than the cut-in voltage, then the substantial amount of current flows through the diode. In forward bias condition, the depletion region becomes very thinner. So let us understand the forward bias condition better by this diagram. So as you can see here, the positive terminal of the diode is connected with the positive terminal of the battery, and the negative terminal of the diode is connected with the negative terminal of the battery. So as you can see here, in the positive terminal of the diode there are holes, and the negative terminal of the diode there are electrons. So by the positive terminal of the battery, the holes will be repelled toward the junction, and same goes for the electron. So the depletion rate will be smaller in case of forward bias. The conduction will be much higher in case of forward bias condition. Now let's move on to the next topic, which is reverse bias condition of p-n junction diode, which is also very important. When the negative terminal of the battery is connected to the p-type or the positive type and the positive terminal of the battery is connected to the negative type of the diode, then it is said to be the reverse bias mode. The depletion region is increased in case of reverse bias mode, and the diode conductivity becomes almost zero or very low. The current in reverse bias mode is due to the minority carriers and is called the reverse saturation current, and the reverse voltage at which the junction breakdown occurs as reverse breakdown voltage is known as reverse breakdown voltage. So let us understand the reverse bias condition better by this diagram. So as you can see here, the positive terminal of the diode is connected with the negative terminal of the battery, and the negative terminal of the diode is connected with the positive terminal of the battery. So in the positive side of the diode, the holes will be attracted by the negative side of the battery, and same with the negative terminal of the diode will be attracted by the positive terminal of the battery. So the depletion rate will be increased in case of reverse bias condition, and the kinetic conduction will be nearly equal to 0. Now come to the topic voltage and current characteristics in forward bias mode. Voltage and current characteristics of diode is obtained by plotting a graph between voltage and current by taking voltage in x-axis and the current in the y-axis. When the applied voltage is less than the cut-in voltage or barrier voltage, then no current is flowing through the diode and it is almost zero. When the applied voltage is greater than the cut-in voltage or barrier voltage, then the current starts flowing through the diode and the current increases exponentially with the increase in voltage. This explains the VI characteristics for forward bias, and as we can see here, in the x-axis we have plotted voltage and the y-axis we have plotted current, and we can see here the current increases exponentially with the increase of voltage. So let us understand what is 0.3 and what is 0.7 volt over here. So when we have discussed earlier, when the applied voltage of the battery is greater than the cut-in voltage, which is or barrier voltage, which is 0.3 for germanium and 0.7 for silicon, is greater than these voltages, then the current will increase exponentially with the increase in voltage. So this is all about the VI characteristics or voltage current characteristics for our next topic is VI characteristics in reverse bias mode or reverse bias condition. The VI characteristics of reverse bias diode is obtained by plotting a graph between the voltage and current by taking voltage in negative x-axis and the current in the y-axis. When the applied voltage is gradually increased from zero, then small amount of current called leakage current flows in the diode, and this leakage current flows up till knee voltage. At knee voltage, breakdown of the diode occurs and the current increases rapidly without further increase in voltage. So the voltage remains same for a range of voltage. Only Zener diodes are used in reverse bias condition in voltage regulators. As you can see here, this is the VI characteristics or voltage current characteristics for reverse diode, reverse PN junction diode. So the voltage is plotted in the negative x-axis and the current is plotted in the y-axis. When the applied voltage is gradually increased from zero, then a small amount of current called the leakage current flows in the diode, and the leakage current flows up till this breakdown voltage or knee voltage. At the knee voltage, breakdown of the diode occurs and the current increases rapidly without further increase in the voltage. So the voltage remains same for a range of voltage. So this voltage is also known as the Zener voltage, where the breakdown of the diode occurs. So in the reverse bias condition, the diode can be used as the Zener diode, which is also used as a voltage regulator.
That's all about it for today. Thanks for watching and keep listening for more updates. Don't forget to like, share and subscribe our channel Tektronics if you like this video and want more videos from us regarding any query about electronics. Thank you.